10.7 areas of circles and sectors. So you should already be familiar with the area of a circle. Pi times radius squared or radius squared pi. It's the same thing. It doesn't matter the order. So we're going to get into it. Circle from the center to the edge is your radius. When you cut straight down the middle like this would be your diameter. So it says the radius of bullseye of the dartboard is 4 inches. So a lot of times you should draw in what you know. So that right there is 4. Each additional ring is 4 inches. So I'm saying this right here is 4 inches and this right here is 4 inches. What is the area of the shaded region? Well, first, it looks like it's the area of this whole circle right here, but this is cut out. Now, whenever something looks cut out, that means you are subtracting something. So first we have to go back to what the radius of the middle circle is. And if I go from the radius from the center to the edge, this was 4 and this was 4. So this right here would be 8. So when I'm looking at this, there's two things that we can do here. We have radius squared times pi. That's my area. I would have to subtract my smaller circle. So I have to subtract my 4 radius squared pi. Now I would actually multiply that out. 8 times 8 fell on the floor, picked it up, it was 64. 4 times 4 is 16. Now, if I ask for your answer in pi units, remember this is just kind of like an x here. I'm still taking 64 of something minus 16 of something. So if you did 64, if I asked for this in pi units, this would be 48 pi. In this case, we're talking about inches squared. Now, if I didn't want pi units, I would hope that you would try to use the pi button. So 64, my pi button is right here. So I'm going to push second pi minus 16 second pi. Now, if you use 3.14, you will still get the same answer. It's just going to be a little bit off. So I'm going to say this is 8 inches squared. So that's the area of the shaded region. Now we get into finding the area of, oh my gosh, the area of a sector. So what a sector is, it's kind of like think of a slice of pizza. That's what a sector is, a slice of pizza. Now, when we just want this section, this is the part that's added to it. Okay, what that is saying, this right here is an arc, the measure of your arc, AB, or your angle, your central angle. So this central angle is saying the portion of the whole area, because this right here gives us the area of the whole circle, but this is just a portion of it. So this right here, let's say if this was equal to 100, if I wanted to find the area of that, I would do 100 over 360 times, if my radius here was 2, radius squared times pi, let's say. So again, you can keep this in pi units, and what I would do in my calculator, I would just go 100 divide by 360 times 2 squared, which is 4, and that, I'm going to change that into a fraction. So 10/9 pi. So that's not really a proper way that we are going to represent a number. So I'm going to actually multiply that by pi. So this is the same thing as 3.49. Again, it's pretty small units squared because the fact that our radius that I chose was pretty small. So same type of thing here. I have my radius squared times pi. Now I'm going to multiply that by the area, or the arc is 36 over 360. So I did 6 squared times 36 divided by 360. So if I wanted this in pi units, it'd be 3.6 pi. Or I can multiply that by pi actually and get 11.3. My units here, I don't have units, so that would be my answer. I want you to pause the video and try to do B by yourself right now. You should have gotten 1.5 pi, because right here you have to add the 45 plus the 90, so to figure out this whole angle, which is 135. So again, I did 2 squared times 135 divided by 360. This is what's in pi units. That's where that 1.5 comes from. So I don't multiply by pi yet. Or if I multiply by pi, I get 4.7. So now we're going to talk about a segment. A segment is basically the kind of the cross. So this is the area of a sector. When we're looking for a segment, this is what a segment is. When you have a line that's drawn, but it doesn't go through the center. This right here is a segment of that circle. You take the area of the whole sector, and you subtract the area of the triangle, and you get the area of the segment. Now when I'm doing the area of the triangle, this is where we want to maybe use the 1/2. In this case, it would be r times sine of my central angle. That might work, or if I have my base and height. These right here are 90 degrees, so that makes my life a little bit easier. So just looking at this one, when I'm finding the area of my sector, and we're not going to leave it in pi units, so it's radius squared times pi. That's the whole thing. I have to find the area of this sector right here, which would give me 90 over 360. I have to subtract the area of this triangle, so that's this part and this part. You could use this equation. I'm going to use the fact that we have the base, and whenever you have a radius, it's always the same. So the base times height divide by 2, and that will give me my area of my sector, or my segment, sorry. So this is what I typed into my calculator. So 3 squared times pi times 90 divided by 360, that's the area of the sector, minus my triangle. So the area of that segment would be about I'm going to round to 2.57. I want you to pause the video and try D by yourself. You should have gotten 49.21. So again, here's my radius squared times pi, that section of that whole sector, minus the area of my triangle. Notice how when I plug it into my calculator, I leave it all in 1. Because this is all multiplying, there's no adding or subtracting here. This is going to take this number and subtract this whole number. So I get 49.21. Now this is where we're getting into using that other equation. So find the area of this sector right here is radius squared times 5 is 60 over 360. Now when we find the area of the triangle, remember my radius is always the same. So when I'm looking, I can use that equation for sine. So 1/2 times my side times my sine of my angle. So right there, I can plug that in to figure out my area of my segment. If I plug that in, oh, that glitters bad. Again, notice I leave everything in one stop shop. This would be about 2.26. I want you to pause the video and try to do D by yourself. Remember, this arc is the same thing as this central angle. You should have gotten 2.4, and looks like we're going to round that up to 6. Challenge question. I want you to try to pause the video and try to do this by yourself. Pause the video, try to do this by yourself. So you should have first did your segment. So it's still going to be the area of that sector. So this piece of pi, subtract my triangle. This part right here is 41.097. Then I take the area of my whole circle, the whole thing, and subtract just this little guy, because that's actually the little guy that we're actually subtracting from. We're cutting that part out. So if you did that, and again, my units now here, centimeters, would be 411.29 centimeters squared. And there you have it. You are that much smarter, and I'm so proud of you. Have a grand, have a wonderful day.